Hello again. So we're on to 4.5, and here, at least for me, this is where the fun begins in calculus. I'm smiling in case you can't tell. So, a reminder here that the slope of the tangent line to the graph, that equals, or it means the same thing as us saying the derivative, which we know we can write the derivative as dy with respect to dx. We can also write that as our function prime of fx, or we can write that as y prime. All these things mean the same. And so far, in order to find the derivative, we've used the limit as h approaches 0 of f of x plus h, subtract f of x, all divided by h, a long process. Today we're going to start learning the first rules of differentiation, or the first rules to find the derivative a simpler way. Okay, here's the rule. Here's the first rule. So we've got our function, f of x, and let's say it equals, a is any number, then we've got our x variable, and then it's to the power of n. If we want to take the derivative of that function, then here's the rule. The derivative will equal the same a, same number in front, multiplied by n. N is the exponent. Same x to the power of the original exponent, subtract 1. Here's what I mean. So let's say, for example, right here, f of x is equal to 4, so a in this case is 4, x to the power of 3. Then the derivative of that, f derivative x, would equal the same a, 4, multiplied by n, the exponent, which would be 3, x to the power of 1 less than the exponent, so we would see then to the power of 2. So the derivative of 4x to the power of 3 is 12x to the power of 2. Voila! This is the first elementary differentiation rule, and we're going to experiment and use it in this lesson. Number 1 is asking you to find the derivative of y. Now, if we think about this, I drew the sketch here. If we're looking for the tangent line to this, well, a tangent line to a line would be itself. It would be this horizontal line with a slope of 0. The derivative, you can write this down, the derivative of any constant term, like for example 17, is 0, always. Okay? Number 2, we see f of x here is equal to the square root of 3. We can rewrite the square root of 3 as the power of a half. You can look back and remember your radical and exponent laws here. Either way though, there's no x here. We are still taking the derivative of a constant, so f prime of x is going to equal 0. Moving on. E is also a constant. It's similar to pi. You can see its value here. Y prime, or the derivative of 3e, is 0. 3e is a constant. Okay, number 4, we start using our first elementary rule up in the red box there. We see here that y prime is going to be equal to, now the coefficient here is 1, so we do 1 times 5, that's the exponent, comes down in front, times x to the power of 1 less than that exponent. There we go. Y prime is 5x to the 4. If you flip the page, I've written the rule over here on the right. We see the function y is equal to x to the power of 3/4. Our elementary rule says that then y prime, the derivative of y, will be, a is 1 here, so it's going to be 1 times 3/4 times x to the power of 3 over 4 minus 1. Or if we do that with fractions, 3 over 4 minus 4 over 4, our final answer will be 3/4 x to the power of negative quarter. Again, what does that mean? Okay, it means that here's the function. We could make a graph for it. At any point on this function, this is the equation to the line that's going to be tangent to that function. Let's look at number 6. What we want here is our original function to be in this form, a coefficient times x to a certain power. So here we're going to rewrite this function to be 1 times x to the power of negative 3. Remember your exponent rules. The negative in the exponent makes it reciprocate. So now that we have that, we can easily write the derivative of f of x will be, bring the 3 down, negative 3 times x to 1 less than this exponent, negative 3 minus 1 to the power of negative 4. Okay, moving on to number 7. Again, I want to write this in the correct form. This is going to be x to the power of 1/4. Remember exponents and radicals, we've got the 4th root. We can put that as 1 over 4. This one comes from the exponent on x. Once it's in that form, the f prime, or the derivative of f of x, equals, bring the exponent down in front, times x to the power of 1 less. So 1 over 4 minus 4 over 4 will give us 1/4 x, the negative 3/4. Number 8, we can rewrite this function as x to the power of 4 over 5. Again, this root sign goes as the denominator of the exponent, and then y prime. So I'm choosing now to write this derivative in whatever form the original function was. That's the form I used to represent the derivative. 4/5 comes to the coefficient, x to the power of 1 less, so it's 4/5 minus 5/5. You don't need to write this step down. I'm writing it just to show you. You can usually do this in your head. 4 minus 5 would be minus 1/5 as an exponent. Okay, these next 4 questions I've already written in green the original function with the coefficient, the variable, and the exponent. If you have issues or you're not understanding these rules that you've learned in the past about manipulating exponents and radicals, give me a text, okay? And I can explain each one of these to you separately. We're going to need to be fluent in using exponents and radicals to find the derivative. Okay, so then the derivative here, I'll turn to blue. We've got y prime here. We're taking the derivative of x to the power of negative 2/3. The exponent comes down in front to find the derivative. We've got x, and then we've got negative 2/3 minus 1. Negative 2/3 minus 3 over 3, which equals negative 5/3. Here it's already in the form we need, so f prime, or the derivative, or the equation of the tangent line to f of x is going to equal 10 times 4. You could write 40 there, I'm just showing you, and 4 minus 3. It's going to equal 40 x to the power of 3. Oops, 4 minus 1 here, I'm sorry. Number 11, y prime is going to equal, now 11 times negative 2 is negative 22 x to the power of negative 2 minus 1, negative 3. And f prime here will be a half times 4, or we have 4 over 2 here, which is 2x. 1 over 2 minus 2 over 2 will give me minus a half. Okay. Okay, here's the assignment. You'll notice that this assignment is oral exercises. So we're supposed to do this out loud in the classroom. These ones go really quick. There's about 50 of them, but still, most of them you can look at them and find the derivative using this rule. Now, you can follow the explanation or the procedure that's listed in Google Classroom to find the correct answers. I'm not quite sure how I'm going to do that yet, but either we'll zoom and I'll tell them to you, or we'll make a flip grid and you'll tell them to me, but look for how we're going to do that. Okay, good luck using this derivative rule, differentiation rule.